All right, hey everyone, I'm David Room, and today we're going to be doing a little bit of chill game development. I'm actually joined here by Katie Room. She's going to hang out. And part of what we're going to try to do here is we're going to test the Discord echo or voice chat echo cancellation, because last time when she joined, I thought everything was working fine, and then I listened to the stream later and there was this echo. So that was kind of unfortunate. So we will take a look at that as well. Okay, so I'm just gonna share a link on Twitter now that we're live, and then we can get started. I've got something kind of cool to show you guys that I've been working on. I'm pretty excited about. I always sometimes with my project I'm not sure what to work on, and then I go down a rabbit hole and come up with something cool, and that's kind of what I'm doing now. So okay, just sharing a link here on Twitter. And I'm gonna grab the link here. Okay. Cool. All right, so I'm gonna just bring up my work log here and show a little bit of what I've been doing the past few days. I haven't had a ton of time. I've kind of been busy getting back into my day job and not feeling super well, so I don't have a ton of progress to show you guys since the last time, but I have done some interesting stuff. So last time I think we were starting to look at a new fighter design. I think we were working on this during the last live stream. It's this little three-sided fighter, and it's kind of a interesting design. There's some challenges kind of thinking through it and modeling it out live, but I'm happy with what I came up with. And then I think the next day I kind of updated some colors and got it into the game, and then I thought, you know, part of what I was trying to do with this design, and I think I mentioned it, was I wanted to try to see if I could make a sort of variation on it for a totally different ship class. So that's what I did. And let me actually just gotta comment something out here, and then I can show you guys what that looks like. So this was originally a small fighter, but I wanted to see if I could make a similar design that was like quite a large ship, actually a frigate. So the fighter I think is like about 20 meters long. This frigate is about 200 meters long, and they're quite similar designs. They both have this three-sided design, with 3 engines in the back and radiators kind of opposite the engines. Here's the frigate. So I'll show a couple more updates. So that was the first iteration of it. Then I've gone through, I started adding some weapons. I came up with a big missile launcher weapon, which I need to actually implement the logic for in game, but it looks pretty cool, I think. And then I added some additional hull shape detail for the large version. For the large version, I set the drives out farther, and I kind of have them aligned a little differently around the ship. But I think it looks pretty cool. So we have kind of a swapped orientation of the drives versus radiators, and I have the radiators in between the drives on the large version. And there's additional details that needed to be added to this, but kind of after that stream where I was looking at what content I need, I'm like, I need to start putting effort into making more ships. So this is something that I started working on. And something that I've been thinking about a lot is how to make good livery details and additional markings. So the way the game works currently is all of these different pieces of the ship. They're individual pieces, and each piece can have a different material or color on it, but there isn't a good way to add extra detail. And games of this era did a lot of different things when it came to extra detail. So some games, like for example, MechWarrior 2 did have texture mapping. They used these kind of low-res texture maps. Other games like TIE Fighter had interesting details, and that they seemed to sort of be building out of polygons. And I didn't understand quite how that worked until recently, and that's what I want to share with you guys. But I started thinking about what would it look like to sort of add additional colors and like paint details using polygons. So I came up with something interesting. Oops. I came up with something interesting here, and I'll go into more detail in just a sec, but I came up with a method where I can slice through one of these meshes, like the fuselage, and then I can color different slices that I make of it, different colors, combine it back together, and then use that for paint details. And this is sort of an initial sort of glitchy version of it in the game, and I'll show you what a refined fixed version looks like in just a second. But I want to talk about where the inspiration for this came from, and I always wondered exactly how this was implemented in TIE Fighter, and I finally got to do some research on it this week, and I think it's pretty interesting how it works. And I couldn't find a lot of information about this online, so I wanted to share it with you. Okay, so just for reference, I'm gonna bring up some screenshots of TIE Fighter here. And so there's a couple different versions of TIE Fighter. Sometimes you see screenshots of the enhanced version that has texture mapping. I really prefer the look of the original version, which didn't have texture mapping. So that's what I'm going to show here. And I'm going to be showing screenshots of the original non-CD version, which ran at a very low resolution. I believe there was a CD version that didn't have texture mapping that ran at a higher resolution that would have worked the same way. But I kind of want to focus on how this stuff looked originally. So you can see these are these freighters, and this is kind of a classic Star Wars ship now. It actually kind of made it into the canon after this game. But you can see these freighters, and the polygons and shapes on these freighters seem to have some kind of texture on them, right? And it doesn't really look like a bitmap texture map, but there's like dark lines and different colored grays for different parts of the panels and stuff. Some other examples of this that you can see in the game a really clear example is on um, the TIE fighters themselves. So you have the TIE fighter, and then the panels on the like the I think they're actually supposed to be solar panels on the TIE fighter are a different color, and they seem to be panels or polygons that are kind of overlaid on top of the underlying 3D mesh, uh, offset a little bit from the corners and stuff to make those outlines. TIE Fighter also has this grow shading, so you can see there's different parts of the mesh are kind of shaded together with some hard lines in between them. I think the effect is really very distinct, very distinctive. Here's kind of a more of an in-game screenshot from the replay functionality. And yeah, you can see the same thing here. I think on this capital ship you can see some like different colored panels and details and stuff there. And then one of the more maybe extreme examples of this is on the Carillion transport. So you can see here there's a lot of added detail via these polygons. Free Narnian says TIE Interceptor is, I think he says it's so Kino. Yeah, I agree. It's the TIE Interceptor is a really, really great ship design. And I think something that is cool about the Star Wars ship designs is that they hold up really well, even in this kind of very lo-fi setting, right? It's obvious this is a TIE Interceptor, and this is probably, not more than 100 or a couple hundred polygons here. And, very, very clear silhouette, very clear markings, etc. The Millennium Falcon is kind of the same. Maybe it doesn't hold up quite so well. A lot of these shapes might be better represented with more circular shapes, so you can't do them so well with the low poly markings. But anyway, so just looking at this, I always wondered how this was done, because it doesn't look like texture mapping. I figured it was some kind of polygons. I think I originally thought that maybe this was all done with face colors of the mesh. So maybe one way you could implement something like this is to basically introduce extra polygons, like extra coplanar polygons in your mesh, and then if you can specify that each polygon is a different color, that you could bring these shapes out. But the problem with that is when you start adding a lot of extra shapes like this, the extra polygons would really stack up. It would be actually better if you had some way of overlaying polygons, because making sort of a watertight mesh with those extra shapes is going to end up generating a lot of extra polygons. So I always wondered how this was done, and I finally did some research into the file formats, and I figured out how it actually works. And what I want to show you is how it actually works, and then kind of show you what the slightly more modern equivalent of that is, which is what I'm doing, what that looks like. And then we'll wrap up. I'm going to try to do some live coding, and there's a couple different things that I want to work on, specific kind of markings for a specific craft, and we'll see if we get through that. Some additional functionality that might be a little bit more difficult to implement. So let's take a look at how TIE Fighter, and actually this technique goes back to X-Wing, which came before TIE Fighter, how they implement these ship markings. Just gonna check quick here on the stream. Okay, so we got a few people watching. Nice. And I'm gonna bring that down. Okay, so this took a yeah. Okay. Um, can you talk once? Yeah.
I just want to make sure that because the first thing that I said didn't seem to come through in the video,
Okay.
so I just wanted to say a little bit more and see if it comes through.
Okay. Well, you're showing up for what it's worth. You're showing up in this in the screen capture um,
Okay.
audio, which has come through in the past. So, I don't know if anyone in the
Okay.
chat.
Let me just double check.
I don't know if anyone in the chat can comment if they can hear Katie or if there's an echo. It could be that you're just very low. You might be quieter compared to me since I have the volume on the screen capture turned down. Okay. Huh. Free Narnian says I don't hear anything. That is really strange. Um, are you saying you don't hear an echo, or do you mean you didn't hear Katie talking at all? It could be a. Okay, you think you're really quiet. Let me try something. Can you talk now, Katie?
Okay, here I am.
Okay, I'm gonna turn you down just
I
a little bit. Okay, so you didn't hear her talking. All right, can you try talking again?
hello, hello. It's
Okay,
me,
so
your wife.
I can definitely hear you,
Okay.
but it could be that the device on Discord is wrong, and that's why it's not coming through. It's weird.
Oh.
It's showing up under the screen capture in OBS. I really would like to figure out how to get this working because it's nice. Okay, so he hears you now. Is there an echo, Free Narnian?
I can talk some more.
Yeah.
Hello, hello. I don't see
It
a way to adjust my
no,
mic.
it's not on your side. It's basically just the system the sounds that are coming through my computer. I had it turned way down because
Oh,
of how I was playing music before.
okay.
Okay, so he says for Katie there is a little bit of an echo. Okay. And I wonder why that is. Katie, are you wearing headphones?
I am.
Okay. I have no idea why there would be an echo because I don't hear her with an echo. And and yeah, I don't hear her with an
I've got
echo.
noise suppression on.
Do you have echo cancellation turned on?
I have noise suppression. I don't know
Do you have echo cancellation
where.
turned on? So it
I don't
is
know
if you go under voice and video, and
voice and
then
video.
if you scroll down, so there's like a voice processing section that has echo cancellation and noise suppression underneath it.
I'm gonna have to Google it.
You don't just see it in your Discord settings.
Settings.
So on the left hand side, if you scroll down, there's like app settings, and then there's voice and video.
Voice and video. Ah,
Okay, and then keep scrolling down until you see voice processing, and there's like an echo cancellation setting and a noise suppression setting.
So echo cancellation is on.
Okay. Maybe we have to. Oh, did you turn it off? Did you just turn it off?
Yeah, I just turned it off and back on.
Okay. What if you turn it off and talk a little bit with it off?
Hello, 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 hello.
There's more noise in the background with that. I don't hear an echo that way either. Huh.
Okay, I just turned it back on.
That is so weird.
So I don't know.
Hmm. Well, I guess if it's just a little bit of an echo, we'll probably keep going because you're probably mostly going to be lurking anyway. But we'll have to just experiment with this. Um, we'll have to just experiment with this some other time. I have no idea
Okay.
why there's an echo because I don't hear an echo in my headphones with you. Are you still there?
Yes, I'm still here.
Okay. All right.
Not I
Okay.
don't have anything that I can do.
Okay. Yeah. Well, we'll experiment with it later then. I want to keep going so we don't get too late here.
Okay.
Okay. Yeah. So um, one of the first things that I found, um, was, um, was I started kind of Googling about some of the different file formats and where the ship data for TIE Fighter might be stored. And this actually was quite hard to find information on just itself. But um, in the game, there's a bunch of files, and it seems that most of the ships are stored in a file called, um, see, where is it? It's called species.lfd. And I'm going to actually just open this with a hex editor. So when you open this with a hex editor, um, you can see these header chunks for each of the different ship types. And then there's a chunk of data that's in this certain format, which is called ship format. So ship is the format of the chunk, and then X-wing is the name, Y-wing, A-wing, right? So there's a format for each of the ships, and these are indeed the ship meshes. So I started looking for LFD readers, and I found this one on GitHub, uh, and it does support TIE format or ship format. So you can see here it talks about craft, CPLX, and ship. And unfortunately, though, in his documentation of how the format works, there was a bunch of stuff specifically related to markings that he was like, I don't understand how this works. And somebody actually commented about this in the issues, and they linked to this engine technical details PDF, which linked to another project which does actually have a better implementation of ship format loading. So this is XW Loader, and this project actually, and here's just in this issue is an image of it working. So this is a Unity project. I don't have Unity installed, so I couldn't compile it and run it myself. But here's an example of an exported ship from X-wing, and you can see these red pieces here are the markings that I'm interested in figuring out how they're implemented. So in the wiki here is a discussion of this file format, and a lot of like a good chunk of this this format is dedicated to the mesh itself. I'm not interested in that so much as the markings, so let's kind of skip to the markings. So the the meshes here are built of shapes, and there are there's sets of shapes that will be shaded together with the Garo shading, and the shapes can be have higher vertex counts than just triangles. So in most modern games and in a lot of 3D modeling, you'll use either quads or triangles. So here there can be like higher degree polygons, and also lines. So there's a lot of different shapes that the model can be built out of. But here's the interesting part. So here's marks. So basically each shape that is part of the mesh can have a number of marks, and this kind of goes along with what we were seeing, right? That it looks like there are these shapes that are drawn on top of the mesh, or on top of the 3D model. So each shape can have a number of marks, and the each, let's see here, so okay, so actually, so this is, yeah, it's not each shape can have a number of marks, it's each model has a number of marks, and then each mark is on a particular polygon. So each polygon or shape can have a number of marks, but it's sort of built as a list of marks for the whole model. And then each mark. Oh, okay, I see. Sorry, I'm reading this wrong. So there's a number of marked polygons. For each marked polygon, there's a number of marks. And then for each mark, we have a color. So each of the marks can have a color. And the way TIE Fighter works is the palette is just a 256 color palette where some of the color ranges are used for shading. So it's just one byte is used to describe the color. And then each mark has a mark type, and then depending on the mark type, there's a number of additional pieces of data. And this looks kind of complicated, but in general, the way it works here is that each mark is another polygon that's constructed by adding little offsets to one or more other vertices of the polygon. So there's like a line, 3 corners, 4 corners, 5 corners, different numbers of corners. Like if you can imagine you had a square, you can make a mark by saying, I'm going to offset a little bit from this corner, and then I'm going to offset a little bit from this corner, and I'm going to offset a lot from this corner, and I'm going to offset a lot from this corner, and that would describe a quad that would get drawn on top of that polygon. And I believe the way they describe this is that these marks are always clipped by the polygon that they're drawn on, so they can't go outside. And I think we can kind of see that in the way these edge factors are described. So the way the offsets of the mark corners are described is you have your sort of originating vertex, and then those coordinates can be shifted by a fraction of the distance from that originating vertex to the next vertex in the underlying shape and the previous vertex. So if you can imagine, you could kind of shift in, could kind of shift in and indent corners, or you could shift along to sort of make a polygon off of an edge. But this is a nice way of describing marks that could sort of sit on top of faces in these models. K-Bub asks, I love TIE Fighter so much. Any in-progress previews? So I'm not exactly sure what you're asking. What I'm going to be showing here in a bit is some functionality of my game that I'm developing, which is heavily inspired by TIE Fighter. So I'll show some in-progress work on that. So yeah, and this kind of explains the fact that multiple, like a shape can have multiple marks, explains how we get some of these nice effects that we see. Um, on the Carillion transport, my guess is that this rear surface is divided into quads, and each of those quads has a couple of marks on it. Um, same with the interceptor here. This is probably a triangle, and then there's a quad here, and you can see how these are indented. So this is just kind of a neat way of describing how you could add that detail. Okay, so how would we go about implementing something like this in a little bit more modern engine, right? I'm not writing a software renderer. I don't have the capability to, you know, um, make arbitrary polygon overlays over arbitrary polygon shapes that make part of the model. I'm working with triangular meshes, but I want to have this ability to do these overlays. How do we go about implementing that? Well, let's take a look. So, here in my workbench, I've got something set up. So I'm constructing the big frigate that I was talking about earlier, and we'll take a look at the whole thing. Take a look at the whole thing here. So here's our frigate, and there's a lot of different subparts to this, but we're going to be adding some markings to the fuselage here. So if we extract the fuselage now, this is a singular mesh, and this has 100 vertices, 196 faces. The wireframe looks like this. So I've implemented some functionality in a module here called Livery. And the idea here is that we can describe ways of separating meshes into pieces using sets of planes that will cut the mesh. And then we can separate the mesh into pieces, and all of those pieces are going to be subsets of the original mesh that will lie on its surface. And then what we can do is we can take some of those pieces and use them as markings that will give a different color or a different material and overlay on the top. So I've set up a set of slices here, and each of these slices or sets of slices will represent a stripe. So I have this stripe function where, given a plane, and we can describe a plane with a position and a normal or a direction and a thickness, we will turn that into two planes that will describe the section of the mesh that sits in between them. So the way we do that is we just take the original mesh, add half the offset or half the thickness, and then or the original plane, add half the thickness along the normal, and then the original plane with half the thickness along the opposite direction of the normal. So say our original plane cuts like this. We're basically making one plane that is slightly shifted this way, facing in this direction, and then another plane that's shifted this way, facing in this direction. And then the area of the mesh between those two planes is what will become our stripe. So I'm describing three stripes here, and then we run it through this function, which basically separates the mesh completely using these three sets of planes. Then we have a set of geometry that kind of describes something like painted on stripes. So let's see here. I'm gonna have to run this again. Some window weirdness here. So, okay, so here's our first slice that we've cut out. Here's a part of the second slice, and here's the third slice. So here is basically what is left of the original mesh after we cut those slices out, and then here's the slices. So this will represent, this will be the markings that we're going to add, right? So like unlike TIE Fighter, where we have this kind of complicated language for describing how we're going to sort of overlay markings on polygons, here we're just coming up with polygons that we're going to treat as markings, and we're doing that by slicing our original mesh. There'd be other ways to do this. So for example, you could come up with, you know, flat decals of different shapes that you could just stick on. I'm going to be experimenting with that too going forward, you know, like for panel details or different things like that. But this kind of slicing, I think, is a nice way of coming up with stripy paint type details. Okay, so what I did here is after coming up with these stripes, I just saved them out in egg format, which is the Panda 3D file format. I'm using the Panda 3D engine for various reasons, but I saved them out, and I saved them out with those colors that I was showing just for testing, because ideally we'd be able to describe paint stripes that have different vertex colors and things like that if we want to do some things with that. I'm trying to avoid texture mapping in my game just for stylistic reasons. So to be able to do different kinds of effects, I want to be able to use vertex colors. So I want to make sure that that's working. And then what we can do after this is we can simply add this to our hierarchy of objects that we use to build our ship in the game with some special properties. I'm going to show you what that looks like. So the way that we describe our spacecraft in the game is just with the sort of hierarchical data. This can be either in JSON or YAML format. Here's the YAML file. And here, like for the main fuselage of the ship, we describe a hierarchy of models. Some of these kind of load different things automatically. Some of them don't. But here's where we add the markings. So here we're basically just saying, here's a part that's named markings. We're going to load it from the egg file that we saved. And then we could optionally assign it colors or materials, but we're not going to do that here. So the underlying vertex colors should show through. And then I'm going to just give it this property called marking. And the reason for that is to be able to have this treated as an overlay. There's some special things that we have to do in the game engine, and I'm going to talk about how those work. So let's see here. So when we're loading, if this marking property is set, we're gonna do some special configuration. So the first thing that we have to do is we have to make sure that it will always draw over the top of whatever ship it's attached to. And there would be different ways to do this. One way to do this would be to actually shift those polygons out a little bit, you know, before we save them. But we don't want to do that because we don't want to have weird little artifacts when we're drawing things. We want the paint to look like it's actually stuck to the ship, not hovering slightly above it. So so the way we deal with that is we add what's called a depth offset to the object before we render it, and that will just basically bring it forward a little bit from where it's actually calculated to be. And then we will set the bin. So in Panda 3D, there's different bins for rendering. There's a bin, sort of like a standard bin, and then if you use one as the priority level, then basically those things with level one will be rendered after. So this, we're basically saying we'll render it after any kind of normal object. So like the ship is sort of a normal object. The paint will always render after the ship. So the combination of always rendering it after the ship and that depth offset means that it should always render on top without any Z fighting or any artifacts. And then finally, we set depth right to false. So the way game graphics work is that we figure out which things are in front or behind each other with something called the depth buffer. So when you draw something on the screen, you also store into the depth buffer sort of distance away that it is from the camera, and you only draw a pixel if the depth is less than what's already in the depth buffer. Now here we're shifting the we're doing this depth offset to make sure that it's going to lie in front of whatever it's behind. But because this is paint, we know that it's going to be on an object that's already there. Like, we're not just going to have paint that's free floating in space, right? The paint is always going to be on a ship. So when we're drawing the paint, we don't need to update the depth buffer. So we set depth right equals false. So it'll still check the depth buffer, right? Like if there is one ship in front of another ship, we don't want to draw the paint of the ship that's behind the other one in front of the ship that's in front of the other one. So we want to check the depth buffer, but we don't want to update the depth buffer with that depth offset. The depth buffer is used for some other things like shadows. And if we tweaked the depth buffer too much, we might start seeing like little shadow artifacts and stuff. So we just disable that. There's some other logic that we have to do to deal with how I'm building this hierarchy of objects, but that's not too important. Let's just take a look at what this looks like in the game. So I have a scenario here set up, and all of the logic for the enemy ships is turned off, so we're not going to be getting shot at. We could just kind of take our time looking at the ship. So here it is, and we'll move around here to the side facing the sunlight, and we can see that indeed we have the ship with a very brightly colored paint overlaid on it, and I think that looks pretty cool. And you can see we don't have any Z fighting. We don't have any weird stuff going on. The one thing that you do see is that the paint is overlaying the targeting stuff, and that is because that is also using order 1 in the fixed buffer. So I'm going to change that quick, and then we should see the targeting stuff being drawn in front of the paint. So all we have to do here, we should just have to change that to 2, and then we shouldn't see that happening anymore. Yep. So that looks like what we want. Cool. Okay, so just gonna do a little live coding now. Now that I have sort of this proved to work, I want to try to make a set of paint for a different ship, just to kind of test that this generalizes and maybe sniff out some bugs in my code. We'll see if I run into tricky problems here. I'll probably just have to call it a night because I don't want to be working on this all night. But we'll go through the process of making another set of paint or markings for a different ship and see what issues we run into. Are you still there, Katie? Have I bored you to tears by now?
I'm still here.
Are you still there?
I'm still here.
Okay.
Yeah, can you hear me?
Yeah, I can.
Okay.
Okay, so
Maybe I need to give it a pause.
give what a pause?
My mic a minute before it registers to you. I don't know.
Yeah, there's something weird going on. We'll figure it out though. The thing about this is we normally use stuff like StreamYard, but StreamYard doesn't give you high definition streaming unless you start paying really out the wazoo. And for live coding like this, where you're displaying text and sharing a screen, it just really wouldn't work with the free version. So okay. So yeah, let's just get started. So I'm gonna be working on the UDSC Corvette, and let me just see. Let's forget what the. Okay, so that looks like just this function and. See, yes, that does return some data. So we'll just take a look and see if we've got the right thing here. Okay. All right, so what I'm gonna try to do here is I want to make a pair of stripes that kind of run down the fuselage of the ship. And the reason for that is this ship is a ship that is a kind of ship that appears in my book, Uriel's Revenge, and it's the kind of the hero ship of the story, at least for the first half of the book, and it's called the hero ship in the story is called Martin Luther, and it is gray but has goldenrod stripes. So I've been wanting to I've been wanting to give this ship stripes for when it appears in the game. And I just wanted to check how I described it in the book. So it's just with golden rod stripes running bow to stern down the back. So that gives us a lot of artistic leeway here. But basically, instead of sort of diagonal stripes across, we're going to try to do two stripes that kind of run down. Okay, so we'll set up grab our fuselage here. And eventually I'll build some functionality so that these slices or stripes or whatever could automatically apply different parts as they're arranged on the ship. That might require some better handling of markings across different pieces I don't want to build right now. So we're just going to focus on the fuselage. So we're going to have 2 stripes. And I forget exactly how wide this ship is, so we're going to have to just test and look at it and then see. See if we've got it the right size. Okay, so let's see, the origin on one side will be maybe 4 meters in positive X, and then actually probably more like 6. So each stripe will be positioned 6 meters out on either side, and then instead of facing diagonally forward, the planes will also face in the X direction. So, and I believe the way I set this up, well, I guess we'll see. I think the way I have this set up is that the planes sort of face out from the part that they're cutting out to be the stripe. So we'll want 1 yeah, I guess this will just be X hat, and this will be negative X hat. And the thickness, instead of being 10 meters, will be something like 2 meters. All right, so let's take a look at this, and this will just have a different color for each one, just so each stripe, so we can just look at the stripes separately. Yep. Okay. So, yep, that's exactly what I expected to see. I think we could actually bring these in a little bit. And there's the 2 stripes. Perfect. Yeah, so we're actually going to bring these in a little bit. If we wanted to adjust these so that they didn't run across a edge, we could do that. I think they're going to look kind of nice running across an edge. I guess we'll find out. Okay, so now let's save these out. And I'm not going to bother with the vertex colors here because I want both the stripes to be the same color. So we will not add vertex colors And then we're just going to save this in the Corvette directory. Under fuselage. Okay. All right, so now we should have our egg file in, yeah, right here. Okay, so now let's load it in and attach it to the Corvette, and we'll put it in the same scenario and see how it looks. So for starters, let's just swap the Newton out for the Corvette. Which I believe is the XXXC class. So it's going to be this guy. So currently my mission definitions are just Python code that describes ships and where they start and can set some different things. So that's all that's going on here is I'm just loading that in. And let's run this and make sure that we can load the Corvette. I think we should be able to. Whoops. Some leftover logic from when I was debugging markings that we can get rid of now. All right, and this time we'll just look at it with our viewer. So there it is. Looking pretty snazzy with the new updated radiator design that I talked about before. And let's try to add the stripes now. So eventually I'll build a better system for adding markings to ships. For now, I'm just updating the data structures that describe the parts of the ship. So we'll just add a child here to the fuselage that is markings, Corvette, marking 0, fuselage. We can get rid of this material for now. Actually, we'll just, for now, we'll make this dark green. We'll add a goldenrod material in a second if this works. And then we just have to add our properties with the marking flag. So this is just kind of some boilerplate. Marking. Just do this again. Okay. All right, we'll see if this loads up. Okay, it does. And do we have dark green stripes? We do not. So what is going on? All right. So I'm gonna debug. We'll debug by kind of dropping out of the program if we hit the special marking logic first, and then we'll see what else might be going wrong. Okay, so when we hit markings, we'll exit. All right, so we've definitely got our markings. Let me just try a different material on here just to see if that can sniff out what might be going on. All right, so the next thing I'm going to check is just what we actually saved, because it could be that I saved something that we didn't expect. Okay, something else that we can try here actually is just loading up the markings from the other ship. That might sniff out what's going on here too. Oh, I have to actually type .egg. That's what's going on. I need to catch if it isn't actually loading the model, because I think it's kind of a stupid thing to have it just automatically load something that isn't, that's empty. Okay, let's see. Okay, now this is interesting. So, oh, I got rid of I got rid of, yeah, I got rid of the material. So I need to add that back now. So material is skin. I can't tell whether these black stripes are due to... Oh, I think I know what's going on. I think it's... It might just be the specific angle that this thing is sitting on but it also in the original model, this one has smoothing turned on. So I think I need to turn on I need to do some smoothing when I'm saving out these for things to show up properly. Let's actually just quick, yeah, so auto smooth angle. Let me see what that was for the Corvette. Slash auto smooth angle is 30, so we'll add auto smooth angle of 30 on here. See if that looks any different. Oops. Yeah. So this stripe now is definitely following. Yeah, and see now this stripe is kind of lying in oh, is it lying in shadow? Yeah, I think it's, yeah, I think it's, yeah. So okay, so this is interesting. Because it's a separate mesh, it's getting shaded a little bit differently. So we kind of have this extra shadow, you know, rather than being lit. But yeah, I think that looks pretty good. Let's see this in motion now, and we'll see if we'll see how it looks in motion. I think the shading will look better. So we'll re-enable the behavior trees here for the ships. Okay, now we can and I'm invincible, so yeah, that looks like I expected it to. There might be some occasional shading artifacts like we saw where things kind of come in and out of the shadows. Like whenever things are really close to like being parallel to the sun, since I'm using directional light for the sun, you get these weird effects. I think here you can kind of see it where part of the nose of the ship is black, but the stripe isn't. I think the only real way to fix that would be to have these markings be specifically be faces that are part of the underlying mesh, and that's something that we could implement as well. So that might be an argument for implementing it that way rather than this overlay. I thought the overlay was kind of nice because it could let you swap out different paint jobs and kind of like think of it like decals or paint jobs on ships, where it's sort of a separate thing from the underlying structure. But okay, let's make a goldenrod material, and then we will have accomplished something here. And I might actually even have golden material already. We'll see. So I have my materials in here. Do I have a yellow? Don't think so. We'll copy this dark green one. And we'll call it goldenrod. And let's see, my guess is the RGB values for goldenrod should be something like 0.7, 0.6, 0.1. Let's see how this looks. Yeah, it's a little bright. Could be a little bit more red. So actually, if I just reduce the yeah, that looks really snazzy. If I just reduce the green part, yeah, that looks pretty good. Yeah, and this is interesting. So looking at how this plays with a curved surface, you get a little bit of these. You get a little bit different shading across it. So I would say maybe this approach isn't the best for for smooth shaded objects. But on the plus side, it does kind of imply some structure. So this approach, it might work nice for I'm invincible, so he's just sitting there shooting at me. It might work nice for my camera's all goofed up now. It might work nice for sort of adding details that are supposed to look like they have some thickness to them. So if you do some smooth shading, and you get that shading around the edge. I don't know. It looks kind of retro just the way it is, and I'm with this project I'm always wanting to try to find a balance between making stuff look retro and making it look sort of clean and not being glitchy. So I think it looks pretty good overall. Well, I'm pretty pleased with how this turned out. Seems like there isn't anything fundamentally wrong with this this process. If I can kind of take a test example to something specific that I want to do. So I think we're gonna call it good here for tonight. I had fun doing this stream and sharing with you guys some of what I've been working on, and I'll hopefully in the new year I'm going to get into making some regular project updates. I'm also going to be doing some videos or segments as part of those project updates where I share about some of my influences for this project, and I've got some cool stuff coming in the mail that I'll share next time. So stay tuned. if this kind of thing, game development, talking about old space combat games, 3D modeling using Python, if this is interesting to you, uh, make sure to subscribe, and we'll see you next time.